Hello everybody, welcome to week 7 part 4, pre-processing. So in this part we introduced a preprocessor. Pre-processing occurs before a program is compiled, and the preprocessor directives are lines included in the code of the program, and they are not program statements but directives for the processor. All processing directives begin with the pound or the hashtag, if you call it, and only white space characters may appear before a pre-processing directive on a line. So the include directive causes a copy of a specified file to be included in place of the directive. So the two forms of the include directives are include um, uh, open brackets file name close brackets, or include quotation mark file name close quote. The differences between these is the location the preprocessor search for the file to be included. So if the file name is enclosed with brackets, open and close brackets, that's used for standard library header files. If the file name is enclosed in quotes, the preprocessor search first in the same directory as the file being compiled, then in the same implementation dependent manner as for a file name enclosed in angle brackets. So the defined preprocessing directive is used to create symbolic constants and macros. And a symbolic constant is a name for a constant, and the formats for the define directives is you have define using the pound tag identifier and then replacement. So define identifier and then replacement. So when the preprocessor encounters this directive, it replaces any occurrence of identifier in the rest of the code by replacement. This replacement can be an expression, a statement, a block, or simply anything. So the preprocessor does not understand C++. It simply replaces any occurrence of identifier by replacement. So if we take for example define pi 3.14159, this will replaces all subsequent occurrences of the symbolic constant pi with the number constant 3.14159. Define example, directive example. In this example we have the define directives table size 100, and you can see how each of the variables were defined for this directives using as integers. And so after the preprocessor, it has replaced the table size. In this case replaced it with 100 and 100 in both tables. Writing macros. What is a macro? A macro is an operation defined defined in the define preprocessor directive, and macros may be defined with or without arguments. So the define directive can work with parameters to define function macros, as you can see in this macro definition, to get the max of two numbers a and b. So you have define get max a b, a greater than b, or a semicolon b. So that's how you define in macros that get the max numbers between two numbers. So the replacement text for a macro or symbolic constant is any text remaining on the line after the identifier and the define directive. If the replacement text for a macro or symbolic constant is too long to fit on one line, a backslash is placed at the end of the line, indicating the replacement text continues on the next line. So symbolic constants and macros can be discarded using the the undef processing directive, and this directive undefines the symbolic constant or macro name. And the scope of a symbolic constant or macro is from its definition until it is either undefined with the undef directive, or the end of the line, the end of the file is reached. So if you have an example, then the earlier example was about the table size. So the macro ends when it sees undef directives is used, or the end of the file. Notice in this example the directives don't end with a semicolons. That's because they are not C++ statements. This is in the previous slide we showed the define that can be a directive that can work with parameters to define function macros, and we introduced this macro definition, the getMax macro definition. What this would do is this would replace any occurrence of getMax followed by two arguments by the replacement expression, but also replacing each argument by its identifier exactly as you would expect if it was a function. So the output of this function macro will be 5 and 7. Conditional compilation. So besides the define and the undef directives, you can also use the f directive to create a conditional directive. It's also called conditional compilation. So conditional compilation enables you to control the execution of pre-processing directives and the compilation of program code. They are useful for testing symbol or symbols to see if they evaluate to true. These directives evaluate constant integer expressions. And every if construct ends with end if, just like normal if and end if statements. And directives if def and if ndef are provided as shorthand for if define name and if not define name. So these are just shorthand, so you don't have to write the whole statements if you want to define or undefine a name. And a multiple part conditional processor construct is tested with directives elif and else. So let's consider the following preprocessor code to illustrate some of the conditional compilation characteristics that we just discussed on slide 5. So here we have if ndef null, define null 0, and if. This statement determines whether the symbolic constant null is already defined. So the expression if ndef null includes the code up to and if. If null is not defined, and it skips the code if null is defined. So every if construct ends with and if, as we mentioned earlier. So here we can see how directives f def and if ndef are shorthand for if define name and if not define name. Programmers often want to comment out the code using the normal coding like slash star or slash forward slash star or star slash forward slash, and this does not work. So when using directives, you can use instead if 0, and then you put the code that don't want it to be compiled, which will be your common code between if and end if statements. This will enable the code to be compiled. Simply replace the value 0 uh, in the preceding construct with the value 1. Another good feature of conditional compilation is that it can be used as a debugging aid, where output statements are often used to print variable values and to confirm the flow of controls. These output statements can be enclosed in conditional pre-processing directives, so the statements are compiled only until the debugging process is completed. For example, if you have if def debug c error variable x equal x, this causes the C error statement to be compiled in the program if the symbolic constant debug has been defined before directive if def debug. And this symbolic constant is normally set by a command line compiler or by settings the IDE, for example Visual Studio, and not by explicit defined definition. When debugging is completed, the defined directive is removed from the source file and the output statements inserted for debugging purposes are ignored during compilation. So in larger programs, it might be desirable to define several different symbolic constants that control the conditional compilation in separate sections of the source file. Other pre-processing directives, we have the error directive, which prints an implementation dependent message that includes the token specified in the directive and terminates pre-processing and compiling. It allows generating an error from a specific location in your code. So if you take, for example, if and def underscore CIS 213, then an error is C++ compiler is required. This example aborts the compilation process if the macro name CIS213 is not defined. The other operator is the pragma directive. The other directive pragma is used to specify diverse options to the compiler. This directive causes an implementation defined action. If the compiler does not support a specific argument for pragma, it is ignored and no error generated. We have also the another two operators, the pound and pound, and so these are function macros definitions that can accept two special operators, which are these pose operators and the replacement sequence. So if the operator pound is used before a parameter is used in the replacement sequence, that parameter is replaced by a string literal, as if they were enclosed between double quotes. So if you have a defined strx pound x cout strx, this would be translated to as cout test. Same thing with the operator pound. It concatenates two arguments, leaving no blank spaces between them. So if you have a if you define a glue with the parameters a and b, and you have the double pound operator in between them, this as well also would be also translated into cout test. This concludes week 7 presentations. Thank you.